Hi class, and welcome to our video lesson on properties and changes of matter. In this video lesson, we're going to talk about how do we describe matter and also what happens when matter changes. Before we get into our vocabulary, let's first take a look at what is the difference between a property and a change. When we're discussing properties and changes of matter, a property is describing matter. So think about if you had to write a description of something, that would be what we would call a property of matter. And then changes is how does matter change? Is it changing physically? Is it changing chemically? So those are some things that we're going to discuss in this video lesson. First, let's talk about properties of matter. And properties of matter can also be physical or chemical. Let's take a look at what a physical property is. A physical property is a characteristic that is observed or measured without changing the identity of the matter. So that means whenever you are making these observations, you can either make an observation or you can measure something, but you're not changing the identity of that matter. And identity means the atoms and the molecules that make up that matter will not change in order for you to observe or measure this physical property. They can be detected by using your senses. Some examples of some physical properties are listed here. The color, size, shape, smell, taste. Those are some examples of some physical properties that we could observe by using our five senses. You also have physical properties that can be measured, such as volume, mass, length, height, width, density, boiling point, melting point. Those are also some physical properties. So any kind of measurement that you take for matter can be considered a physical property. A state of matter is a physical property. We discussed states of matter a few lessons back. Remember, matter can be a solid, liquid, gas, or plasma. So that would also be considered a physical property of matter. And then texture, which is the way something feels, could also be considered a physical property. Let's take a look at some other physical properties that we may not necessarily know what they mean, but they can also be physical properties of matter. Thermal conductivity is another example, and that's just simply the rate at which a substance will transfer heat. The state of matter, which is what we've kind of already discussed, that whether it's a solid, liquid, gas, or plasma. Density, a word that you probably have heard of before, but maybe you're not sure what it is. Density is the mass per unit volume of a substance. So it's how much mass is packed into a certain amount of space. That's what we call the density, and that's also physical. Solubility, which is the ability of a substance to dissolve in another substance. So like, for example, if you're making Kool-Aid and you dissolve your Kool-Aid powder and your sugar in the water, the fact that that the Kool-Aid powder and the sugar can dissolve means that they're soluble in water, and that is a physical property. Ductility, which is the ability of a substance to be pulled into a wire. That would also be physical. And then malleability, which is the ability of a substance to be rolled or pounded into a thin sheet. Something like this might be aluminum that's used to make aluminum foil. They have to take it and kind of uh, pound it down into a sheet of aluminum foil. So you could say aluminum is malleable. Ductility, whenever, for example, if they're using copper to make wires, you could say copper is ductile. But all of these are physical properties, which just simply means that these are properties that I can observe or measure without having to change the identity of the matter. Um, let's look at these, a couple of more here. The apple is round and red. That's physical. I'm describing the color and the shape. The boiling point of water is 100 degrees Celsius. That's something that I can measure. That's a physical property. The density of gold is 19.3 grams per centimeters cubed. Also a physical property that can be measured. So these are all physical properties. I'm not changing matter's identity in order to detect or determine a physical property. Now, let's talk about the chemical properties. Chemical properties are properties that can be observed when matter changes into a different type of matter. So now, whenever matter is changing into a different type of matter, then I am observing what is called a chemical property. And in order for me to observe a chemical property, matter has to go through a chemical change, which is something we're going to talk about a little bit later in the lesson. These are some specific examples of chemical properties that we need to make sure we know. Flammability is the ability to burn. So you think about something that's flammable, that means it's the ability to burn. Reactivity is how easily one thing will react with something else. Also a chemical property. And then combustibility. The capability of a substance to ignite and burn when combined with oxygen. So all three of these would be examples of chemical properties. I'm not going to be able to observe these until matter goes through a chemical change and kind of changes into something new and different. Let's take a look here. These are some examples of some chemical properties here. The wood is flammable. You can see that the wood is burning, it's flammable. I would not be able to observe that chemical property until that wood is changed and you actually burn it. Vinegar and baking soda will react when they are combined, producing bubbles, also a chemical property. And then this right here is kind of an example of combustibility. Enough heat to make the fuel ignite and burn in the presence of oxygen. So all of these are examples of chemical properties, and they cannot be observed until matter changes, until matter goes through a chemical change. That is when these types of properties can be observed. All right, let's kind of test our knowledge a little bit before we get into changes of matter. It says, what kind of property am I? I'm going to pause for just a few seconds, and I want you to think about what the answer would be for these examples here. You don't have to write anything down, just kind of make a mental note in your mind about what the type of property these examples would be. Okay, let's kind of have a quick discussion and see if you were mentally thinking the correct answer on these. Number one says the apple is round and red. If you said physical property for that one or thought that, that would be correct. That is something I can observe without changing matter's identity. Number two, the wood is flammable. That is a chemical property. That is something that I can only observe when matter changes its identity. Because when you burn wood, you are not going to have the wood anymore. It's going to turn into ashes and smoke. Number three, the boiling point of water is 100 degrees Celsius. That would be a physical property. That is something that I could measure. Number four, vinegar and baking soda will react when mixed together, producing a gas. That would be a chemical property. This is something that I can observe whenever matter changes. And then the density of gold is 19.3 grams per centimeters cubed. That would be a physical property. That is something that I could measure. Okay? So physical properties are properties that can be observed without changing matter's identity. Chemical properties can only be observed when matter changes into something else. Now, we've been saying the word change a lot when we were talking about properties. Now, let's look at the difference between a physical and a chemical change. Let's first look at a physical change. A physical change is any change in the shape, form, size, or state of matter where the identity of the matter stays the same. So if matter is going through a change and the identity of that matter is not changing, meaning the molecules that make up that matter are going to be the same after it changes, then that means matter has only gone through a physical change. Let's look at some examples here. Ice cream melting. If ice cream melts, that just simply means it goes from a solid to a liquid. It's not changing its identity, it's just changing its state of matter. So it's still going to be ice cream even when it melts and becomes a liquid. That would just be physical. That would be the same case for these other examples. Cutting a watermelon into chunks is still watermelon. Water evaporating, that's just water changing from a liquid to a gas. It's still going to be water, it's still H2O. Breaking a glass into pieces, it just you just change the composition of it, not the composition, I'm sorry. You just change the size and shape of it. So now it goes from a whole glass to pieces of glass. So you're not changing the identity of the matter. So whenever matter does not change its identity when it goes through a change, then that is what we would call a physical change. Now let's look at chemical changes, okay? And we said previously that we can make observations of chemical properties when matter goes through chemical changes. So when matter does go through a chemical change, that is when it is changing into a different type of matter with different properties. Now the identity of the matter is going to change whenever we're talking about a chemical change. And some examples of that would be iron rusting, the process of photosynthesis, because whenever plants go through that process, they are producing or making a new substance that was not there before. Silver tarnishing, that would be silver kind of changing its color because of some type of reactivity that has occurred. Same thing with an apple turning brown when exposed to oxygen. You're having a change in color, so that's going to be some type of reaction that's causing that change. Baking a cake. A lot of things that we do in the kitchen when we're cooking and preparing foods, we're taking raw foods and changing them into cooked foods. And in order for that to happen, it has to go through a chemical change, okay? Where the identity of the matter is changing. That means the molecules are kind of rearranging themselves and making some new substances. Now, let's look at some signs for a chemical change, because sometimes you've got to look for signs to know that, oh, okay, a chemical change has occurred. One of the top signs that we can notice about a chemical change is whenever a gas is produced. So if you have bubbling or fizzing, whenever you combine substances together, typically that's going to be a sign that something chemical is occurring. For example, many of you probably have seen the reaction of combining vinegar with baking soda. You will notice that it bubbles and fizzes, and that's a sign that a chemical change is occurring. If you have a temperature change, sometimes things will get really warm or maybe they'll get cold. That is a sign that a chemical change is occurring. A solid is formed. Sometimes when we mix substances and we form what is called a precipitate, something new, that would also be a chemical change. A permanent color change, something like that with the previous example, silver tarnishing, that would be an example of a permanent color change. So that would be something chemical. When the leaves start to change colors in the fall, whenever the temperature starts to change, that's also a permanent color change. That's a chemical change. And then an odor change. Sometimes you notice this a lot with foods when they've spoiled. The odor of them is going to be different, and that's because all of those reactions that are happening within that food as it starts to spoil, that would also be a sign that a chemical change has occurred. So these are our 5 signs that we want to look for if we're trying to determine if a chemical change has occurred or not. Okay? All right, let's look at some examples, kind of previous like what we did with properties of matter, but now we're looking at physical and chemical changes. We've got 6 different examples here. Okay? And we've got some little words down here. We're going to kind of drag them up to see if we are correct with our answers. The first picture here is showing a fish being cooked in a pan. Well, I'm taking raw food and I'm changing it into cooked food, and there is some type of reaction that's going to happen to make that occur. So that is going to be a chemical change. Okay? What about ice melting? If you were thinking physical for that, then you are correct. The ice is just going from a solid to a liquid. It's not changing the identity of the substance. It's still water. It's still going to be H2O molecules that make up the ice, solid ice, as well as the liquid water. Okay, wood burning. That would be a chemical change. Whenever we burn wood, we're making and producing a new substance. You get ashes. You also would get some smoke and gases that are given off and produced. Okay? All right, this banana here that this monkey is holding, it's starting to rot and go bad. And he's putting his hand over his nose because there's probably an odor change that's coming with this banana spoiling. That would be a chemical change. Okay? There's going to be reactions and reactivities that happen that causes this banana to change its color and also possibly have an odor. Okay? Number 5 is showing water boiling. And sometimes when students see the bubbling of water, they're thinking something chemical. But with water boiling, you will see bubbles, but that's just the water changing into water vapor, which is a gas. So this is just liquid water changing to a gas. That's just evaporation. I'm still going to be having, or I still have the same type of substance. It did not change, so that's just physical. And then our last one here is slicing a piece of bread. So I'm taking a whole loaf of bread and slicing it into smaller pieces. That's just physical because I am not changing the identity of the matter. We have now reached the end of the properties and changes of matter video lesson. Please make sure that you have recorded and completed all of your notes and you are attaching them to the correct pages in your notebook. There is also a follow-up handout which has already been given to you that you are now to work on. There.